Our topic is curve sketching of a polynomial. Let us consider that a polynomial is of the form y is equal to fx is equal to an x to the power n plus an minus 1 x to the power n minus 1 plus an minus 2 x to the power n minus 2 plus so on a1x plus a0, where an is not is equal to 0. Here you see that what is the degree of this polynomial? The degree of this polynomial is n. That is the maximum power of the variable is n. So the degree of this polynomial is n. And the coefficient of x to the power n, that is an, is known as the leading coefficient. Okay, this is known as the leading coefficient. Now friends, you have seen many types of curves in life. Okay, one curve I am showing here. This type of curve is very familiar to you. This is actually the parabolic curve, and see that there are only one turning in this curve. Only one turning in this curve. So this is the polynomial of this curve is quadratic. The polynomial of this curve is quadratic. I am showing another curve. Say this curve. You have also seen this type of curve also. Okay. See that there are two turnings in this curve. Here and here. So the polynomial of this graph is a cubic polynomial. The polynomial of this graph is a cubic polynomial. Finally, I am showing another one. See that this one. This type of graph is also available. Here you find that there are three turnings. 1, 2, 3. So the polynomial of this graph is biquadratic. Okay, this is for biquadratic polynomial. Now let us, friends, we take a polynomial, say y is equal to fx. Okay, say the leading coefficient of this polynomial be a, which is greater than 0. We considered here the polynomial, the degree of this polynomial be n, and n is odd. Okay, the degree of this polynomial is odd, and the leading coefficient is greater than 0, that is positive. Okay, if the degree of the polynomial is odd and the leading coefficient is greater than 0, then the curve ends will be in the opposite direction, like this one. Okay, like this one. When a is greater than 0, then the first end will be in lower direction, that means in the downward direction, and the final end will be in the upward direction. Okay, you should keep it in your mind. Again I repeat, when n is odd, then the curve ends will be in opposite direction, maybe in this way or maybe in this way. Okay, now when a is greater than 0, that is the leading coefficient is positive, then the curve will be of this form. That is, the first end will be in the downward direction and the last end will be in the upward direction. So I draw this curve. This is the curve. This is x-axis, this one is y-axis. Say this one is the curve. Very simple. Now friends, look at this graph. Here you see that if I draw the tangents at these extremities, the slope of these tangents will be equal to 0, since they are parallel to x-axis. They are parallel to, these two tangents are parallel to x-axis. Okay friend. Now first of all we have to find out dy dx. Okay, find dy dx. Find dy dx. Next you consider dy dx is equal to 0. Okay, first thing is you have given the curve y is equal to fx. Next you find, number 1, you find dy dx, okay, dy dx. Next you consider dy dx is equal to 0. From these one you will find two values of x, okay. Say one is alpha, another one is beta. Why do you get only two values? Because from this curve you said there are two turnings in this curve. So for this you will find two axes. One x is alpha, another x is beta, okay. Now in each axis you will find two heights. One is this one, another one is that one. This is actually f of alpha and this one is f of beta, isn't it? One is at the point x is equal to alpha, you are getting the height f alpha, and at the point x is equal to beta, you are getting the height f of beta. Now see that this f alpha is positive, okay. F alpha here in this example, f alpha is positive. Again I repeat, here at the point x is equal to alpha, that is at x is equal to alpha, f of alpha is positive, isn't it? And at the point beta, f of beta is negative because the height is on the downward direction of the x-axis with respect to x-axis. So you see that the sign is changing from positive to negative. The sign is changing from positive to negative. Whose sign? The values of fx actually. First value of fx is f alpha, second one is f beta. So the sign is changing from positive to negative. For this, the curve will cut the x-axis at 3 points. So the x-axis at 3 points, so there are three real roots. And you are looking that these points are respectively this one, that one and that one, okay. Here A, B, C are the three real roots. Now I shall show another graph, okay. Friends, let us consider that another curve, say y is equal to fx, and here we consider the curve is of this form, okay, where you will find that the degree of this polynomial is even, say, okay, the degree of the polynomial is even, n is even, and the leading coefficient, that is a, is greater than 0. Now friends, when the leading coefficient is greater than 0, and the degree of the polynomial is even, then the curve ends will be on the upward direction. Again I repeat. Y is equal to fx is considered. N is the degree of the polynomial, okay. Now n may be even or odd. When n is even, then the curve ends will be in one direction, maybe on the upward direction or maybe like this in the downward direction. Now I am taking these curve ends in the upward direction because the leading coefficient is taken positive. A is greater than 0. This is taken, okay. Mind it, A is greater than 0, leading coefficient is greater than 0, and n is even. For this, the curve ends in upward direction. Now I am drawing this one, okay. Say the curve is this one. This is the curve, x-axis, y-axis, origin. Now friends, you see that there are three turnings. 1, 2, 3. So if you draw three tangents at this point on the turnings, then you will find that these tangents are parallel to x-axis, so that dy dx is equal to 0. What is dy dx? Dy dx actually the slope of the tangents, and this tangent is equal to 0. Okay, so first of all you find dy dx. Okay, find dy dx. Next is consider dy dx is equal to 0. Why? Because tangents are parallel to x-axis. For this dy dx is equal to 0. Now from this one you will find, according to the rule of this curve, x is equal to 3 values, 3 real numbers, respectively alpha, beta and gamma, say. Okay, this point is alpha, this point is beta, and this one is gamma. And in each point alpha, beta or gamma, you will find 3 verticals. Okay, one vertical, this vertical is f of alpha, this is f alpha. Next vertical is f beta, and the third vertical is f of gamma. Okay, this is f gamma. Now friends, you see that from x is equal to alpha you are getting f alpha, and this f alpha is negative. This is negative. Okay, second one is f beta. From this one you are getting f of beta, and this is also negative. This is also negative. From this graph you are looking, na, f beta is negative at the below of the x-axis, and from x is equal to gamma, f of gamma is also negative. This is also negative. Now see that from this one or that one there is no sign changes. There is no sign change. Okay, negative to negative, negative to negative, no sign change. Na? So for this, the curve, the given curve, this is actually y is equal to fx. The given curve will cut the x-axis at only 2 points. This point and that point, at these 2 points. So the curve y is equal to fx has 2 zeros. That is, fx is equal to 0. Fx is equal to 0 has 2 real roots. 2 real roots, because this curve fx is cutting the x-axis at 2 distinct points. Thank you.